What does an electric circuit mean? Option 1, a closed path for electrons to flow. Option 2, an open path for electrons to flow. Option 3, a device to store electric charge. Option 4, a method to stop electric flow. The answer is, option 1, a closed path for electrons to flow. Define the unit of current. Option 1, volt. Option 2, ohm. Option 3, ampere. Option 4, watt. The answer is, option 3, ampere. Calculate the number of electrons constituting 1 coulomb of charge. Option 1, 6.25 multiply by 10 to the power of 18. Option 2, 1.6 multiply by 10 to the power of minus 19. Option 3, 1 multiply by 10 to the power of 6. Option 4, 9.1 multiply by 10 to the power of minus 31. The answer is, option 1, 6.25 multiply by 10 to the power of 18. Name a device that helps to maintain a potential difference across a conductor. Option 1, resistor. Option 2, capacitor. Option 3, battery. Option 4, inductor. The answer is, option 3, battery. What is meant by saying that the potential difference between 2 points is 1 volt? Option 1, 1 joule of energy is used to move 1 coulomb of charge between the 2 points. Option 2, 1 watt of power is used to move 1 coulomb of charge between the 2 points. Option 3, 1 coulomb of charge is used to move 1 joule of energy between the 2 points. Option 4, 1 joule of energy is used to move 1 watt of power between the 2 points. The answer is, option 1, 1 joule of energy is used to move 1 coulomb of charge between the 2 points. How much energy is given to each coulomb of charge passing through a 6-volt battery? Option 1, 6 joules. Option 2, 12 joules. Option 3, 1 joule. Option 4, 3 joules. The answer is, option 1, 6 joules. How much work is done in moving a charge of 2C across 2 points having a potential difference 12 volt? Option 1, 12 joules. Option 2, 24 joules. Option 3, 6 joules. Option 4, 3 joules. The answer is, option 2, 24 joules. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohms? Option 1, 0.18 ampere. Option 2, 0.36 ampere. Option 3, 1.83 ampere. Option 4, 2.2 ampere. The answer is, option 1, 0.18 ampere. How much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohms? Option 1, 2.2 ampere. Option 2, 1.8 ampere. Option 3, 4.4 ampere. Option 4, 2.0 ampere. The answer is, option 1, 2.2 ampere. On what factors does the resistance of a conductor depend? Option 1, length and area of cross-section. Option 2, material and temperature. Option 3, length, area of cross-section, and material. Option 4, length, area of cross-section, material, and temperature. The answer is, option 4, length, area of cross-section, material, and temperature. Will current flow more easily through a thick wire or a thin wire of the same material, when connected to the same source? Why? Option 1, thick wire, because it has less resistance. Option 2, thin wire, because it has more resistance. Option 3, thick wire, because it has more resistance. Option 4, thin wire, because it has less resistance. The answer is, option 1, thick wire, because it has less resistance. If the potential difference across a component is halved while its resistance remains constant, how does the current change? Option 1, the current will be doubled. Option 2, the current will be halved. Option 3, the current will remain the same. Option 4, the current will be tripled. The answer is, option 2, the current will be halved. Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? Option 1, alloys have higher resistivity. Option 2, alloys do not oxidize easily. Option 3, alloys are cheaper. Option 4, alloys are better conductors. The answer is, option 2, alloys do not oxidize easily. 14. Option 1, use the data in Table 11.2 to answer the following. A. Which among iron and mercury is a better conductor? B. Which material is the best conductor? Option 2, iron, silver. Option 3, mercury, silver. Option 4, iron, copper. The answer is, option 1, use the data in Table 11.2 to answer the following. A. Which among iron and mercury is a better conductor? B. Which material is the best conductor? Judge the equivalent resistance when the following are connected in parallel. A. 1 ohms and 106 ohms. B. 1 ohms and 103 ohms, and 106 ohms. Option 1, 1.009 ohms, 1.009 ohms. Option 2, 0.99 ohms, 0.99 ohms. Option 3, 1.009 ohms, 0.99 ohms. Option 4, 0.99 ohms, 1.009 ohms. The answer is, option 1, 1.009 ohms, 1.009 ohms. What are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? Option 1, each device gets the same voltage as the source voltage. Option 2, if one device fails, the others continue to work. Option 3, devices can be operated independently. Option 4, all of the above. The answer is, option 4, all of the above. How can three resistors of resistances 2 ohms, 3 ohms, and 6 ohms be connected to give a total resistance of A. 4 ohms, B. 1 ohms? Option 1, A. Series minus parallel combination, B. Parallel combination. Option 2, A. Parallel combination, B. Series minus parallel combination. Option 3, A. Series combination, B. Parallel combination. Option 4, A. Parallel minus series combination, B. Series combination. The answer is, option 1, A. Series minus parallel combination, B. Parallel combination. What is A. The highest, B. The lowest total resistance that can be secured by combinations of 4 coils of resistance 4 ohms, 8 ohms, 12 ohms, 24 ohms? Option 1, A. 48 ohms, B. 1.41 ohms. Option 2, A. 36 ohms, B. 2 ohms. Option 3, A. 44 ohms, B. 1.5 ohms. Option 4, A. 48 ohms, B. 2 ohms. The answer is, option 1, A. 48 ohms, B. 1.41 ohms. Why does the cord of an electric heater not glow while the heating element does? Option 1, the cord has higher resistance. Option 2, the cord has lower resistance. Option 3, the heating element has lower resistance. Option 4, the cord is made of a different material. The answer is, option 2, the cord has lower resistance. Compute the heat generated while transferring 96,000 Coulomb of charge in 1 hour through a potential difference of 50 volt. Option 1, 4.8 multiply by 10 to the power of 6 joule. Option 2, 3.2 multiply by 10 to the power of 6 joule. Option 3, 2.4 multiply by 10 to the power of 6 joule, option 4, 1.6 multiply by 10 to the power of 6 joule. The answer is, option 1, 4.8 multiply by 10 to the power of 6 joule. An electric iron of resistance 20 ohms takes a current of 5 ampere. Calculate the heat developed in 30 seconds. Option 1, 1000 joule, option 2, 1500 joule, option 3, 2500 joule, option 4, 3000 joule. The answer is, option 4, 3000 joule. In a stream of electrons moving through a conductor, what constitutes an electric current? Option 1, flow of electrons, option 2, flow of protons, option 3, flow of neutrons, option 4, flow of positrons. The answer is, option 1, flow of electrons. Conventionally, the direction of current is taken to be option 1, the same as the flow of electrons, option 2, opposite to the flow of electrons, option 3, the same as the flow of protons, option 4, opposite to the flow of protons. The answer is, option 2, opposite to the flow of electrons. The SI unit of electric current is option 1, volt, option 2, ohm, option 3, ampere, option 4, watt. The answer is, option 3, ampere. What do we use to set the electrons in motion in an electric circuit? Option 1, a resistor, option 2, a cell or a battery, option 3, a voltmeter, option 4, an ammeter. The answer is, option 2, a cell or a battery. The potential difference across the terminals of a cell is measured in option 1, amperes, option 2, ohms, option 3, watts, option 4, volts. The answer is, option 4, volts. What is the SI unit of resistance? Option 1, ampere, option 2, volt, option 3, ohm, option 4, watt. The answer is, option 3, ohm. According to Ohm's law, the potential difference across the ends of a resistor is directly proportional to the option 1, length of the resistor, option 2, current through the resistor, option 3, material of the resistor, option 4, area of cross-section of the resistor. The answer is, option 2, current through the resistor. The resistance of a conductor depends directly on its option 1, length, option 2, area of cross-section, option 3, temperature, option 4, voltage. The answer is, option 1, length. The equivalent resistance of several resistors in series is equal to option 1, the sum of their individual resistances, option 2, the product of their individual resistances, option 3, the average of their individual resistances, option 4, none of the above. The answer is, option 1, the sum of their individual resistances. The electrical energy dissipated in a resistor is given by option 1, watts equals volt divided by I, option 2, watts equals volt multiply by I multiply by T, option 3, watts equals volt divided by I multiply by T, option 4, watts equals volt multiply by I. The answer is, option 2, watts equals volt multiply by I multiply by T. Thank you for watching this video. Please subscribe and click the bell icon for notifications about future videos.